The heart of the galaxy is a riot of radiance, a dense thicket of burning spheres where the sky is never truly dark. Within the crowded spiral arms of the Milky Way, the cosmic neighbourhood is a tapestry of gold, azure and violet gas. Thousands of suns crowd the horizon, their gravitational hands locked in a slow eternal dance. Dust clouds, thick with the heavy elements forged in the bellies of dying stars, billow like smoke across the celestial stage. This is the world of the known, a place where light is a constant companion, and the next star is always a mere few light-years away. But as the journey carries the observer outward, away from the spinning disk of our home, the familiar glitter begins to fail. The dense clusters of the galactic core give way to the thinning suburbs of the rim, and then, quite suddenly, the shore ends. The traveller leaves the last outposts of the Milky Way behind, and the great spiral becomes a receding jewel, then a smudge, then a single point of light among many. Usually the intergalactic sea is dotted with the distant lanterns of other island universes. The neighbouring galaxies should pepper the darkness like grains of sand on a black beach. Instead, the view forward begins to drain of all colour and form. The distant galaxies start to vanish. One by one, the faint smudges of light are extinguished, not by clouds of dust or the interference of gas, but by the sheer, terrifying absence of anything at all. The stars thin until they are gone. The nebulae vanish. The very concept of a horizon dissolves into a uniform, unyielding ink. This is the entrance to the Boots Void, a region of space so vast that it defies the fundamental architecture of the cosmos. In a universe defined by its intricate web of matter, this is the frayed edge of the fabric, a hole in reality that stretches for 330 million light-years. To cross it is to enter a desert so profound that even the swiftest messenger in existence, the photon, begins to feel the weight of its journey. Light, having travelled for millions of years across this chasm, finds no surface to strike, no eye to perceive it, and no atom to scatter its energy. It becomes a weary ghost, haunting a cathedral of silence. The light does not just travel, it stretches and tires, its wavelength pulled toward the red end of the spectrum by the relentless expansion of the nothingness it traverses. The silence here is not merely an absence of sound, but an absence of influence. In the crowded regions of the universe, gravity is a constant pull, a tug from a neighbour, a nudge from a passing cluster. Here, the gravitational tides go slack. The traveller moves through a realm where the laws of physics seem to operate in a vacuum of purpose. The vacuum is so perfect that it feels heavy. The blackness is not the blackness of a night sky seen from a planetary surface, which is always tempered by the atmosphere or the glow of the moon. This is a primordial dark, a shadow that existed before the first stars were kindled and will remain long after the last one has flickered out. It is an ocean of nothingness so wide that the light from a galaxy on the far side would take hundreds of millions of years to reach the other, arriving as a faint, exhausted memory of a world that may no longer exist. To look into the Boots Void is to stare into a dark mirror that reflects only the profound insignificance of the material world. If the Milky Way were a single grain of sand, this void would be a wasteland the size of a continent, empty of all but the most scattered and lonely of atoms. The scale of the abyss mocks the human ego. Everything we have ever known, every star we have named, and every galaxy we have catalogued exists within the busy, crowded filaments of the cosmic web. We are used to a universe of things. We are accustomed to the presence of matter, the warmth of radiation, and the structural integrity of gravity. The void strips these comforts away. It is a place where the logic of a crowded universe fails, where the density of matter drops to nearly zero, and where the distance between 2 points of light is an impassable gulf that swallows hope and history alike. The traveller feels the shift in the very nature of space. In the dense parts of the cosmos, space is the stage upon which the drama of matter is performed. Here, space is the protagonist. It is an active, expanding entity that seems to push away the encroaching light. The void is not merely a gap between objects, it is a swelling bubble of dark energy and vacuum, a kingdom of the absent. As the journey continues deeper into the heart of this great nothing, the realization takes hold that the universe is not a collection of stars separated by small gaps. It is a vast, echoing hall of emptiness, where the stars are merely the dust motes caught in a stray beam of light. The Bota's void is the truth of the cosmos made manifest, a silent, cold, and eternal abyss that reminds all who look upon it that the light is the exception and the darkness is the rule. Against the backdrop of this immense vacancy, the traveller is reduced to a mathematical point, a speck of consciousness lost in a realm that has no need for observers. There are no landmarks here. There is no north or south, no up or down, only the steady rhythmic pulse of light that has no destination. The mind struggles to grasp a distance of 330 million light-years. It is a number that represents a journey across 3,000 Milky Ways placed end to end, yet in all that distance there is nothing but the occasional lonely hydrogen atom drifting in the dark. The abyss is a reminder that the universe is mostly made of nothing, and that we are residents of the rare, cluttered corners of a reality that is, in its heart, a silent and empty void. The year was 1981, an era when the tools of human observation were finally powerful enough to pierce the veil of the deep cosmos. At the time, the prevailing wisdom of the scientific establishment held that the universe was essentially uniform. On the grandest scales, it was assumed that matter was distributed with the same predictable regularity as the molecules in a glass of water. Astronomers expected that as they looked further into the dark, they would find a steady, unyielding carpet of galaxies, an endless tapestry of light that stretched toward the horizon of the observable universe. Robert Kirshner and his colleagues embarked on what they believed would be a routine survey of the heavens. Their goal was to measure the redshifts of galaxies in a specific patch of the sky, a process that would allow them to construct a three-dimensional map of the distant universe. They focused their instruments on the constellation of Boötes, the herdsman, expecting to find the usual clusters and filaments that define the celestial landscape. They gathered their data with the meticulous patience of cartographers, recording the faint signatures of light on photographic plates and digital sensors. But as the results began to materialize, the expected pattern dissolved. The data did not show a smooth distribution of matter. Instead, it revealed a staggering anomaly. In a specific region of the sky, at a specific distance from Earth, the galaxies simply ceased to exist. Plate after plate came back empty. Where there should have been thousands of glowing island universes, there was only a profound and inexplicable vacancy. It was as if a giant hand had reached into the cosmos and scooped out a massive spherical volume of reality, leaving behind a hole so large that it defied every existing model of cosmic evolution. The shock within the team was palpable. They checked their instruments, suspected their software, and scrutinized their methods, certain that such a massive absence must be a ghost in the machine. A hole of this magnitude, measuring hundreds of millions of light-years across, was not supposed to be possible. According to the physics of the time, the gravity of the early universe should have prevented such a vast region from ever becoming so utterly depleted of matter. The discovery suggested that the universe was not a smooth soup, but a violent, clumpy, and inconsistent froth. When the findings were presented to the wider scientific community, they were met with a wall of skepticism. The idea of a great nothing was an affront to the tidy mathematical beauty of a homogeneous cosmos. Peers argued that the sample size was too small, that the void was a fluke of perspective, or that the galaxies were simply too faint to be seen. It was a struggle for the collective scientific mind to accept that the architecture of the universe could be so radically lopsided. For years, the Boötes void remained a controversial phantom, a piece of data that many hoped would eventually be explained away by better observations. Yet, this resistance was nothing new in the history of human exploration. Since the first maps were etched into clay or drawn onto parchment, humanity has harboured a deep-seated fear of the blank space. The ancient cartographers of Earth, when faced with the unknown reaches of the deep oceans or the frozen wastes of the poles, filled their maps with monsters and myths. They wrote the words, "Here be dragons," across the gaps in their knowledge, unable to tolerate the idea of a world that was simply empty. The blank spaces were perceived as failures of the map rather than features of the territory. Kirshner and his team were the modern heirs to those ancient mariners. By identifying the Boötes void, They had found the ultimate unknown territory. They had discovered that the cosmic web, the very scaffolding of existence, was riddled with holes. This revelation forced a fundamental shift in how we perceive the structure of reality. It moved the focus away from the visible stars and toward the invisible spaces between them. The map of the universe was no longer just a catalogue of light, it became a study of shadow. As the evidence mounted and other surveys confirmed the existence of this massive absence, the constellation of Bootes took on a new, darker significance. The herdsman, who for millennia had been seen as a guardian of the celestial flock, was now known to be watching over the most desolate pasture in existence. This region of the sky became a monument to the limits of human intuition. It served as a reminder that the universe is under no obligation to be uniform, predictable, or comforting. The discovery in 1981 was the moment when humanity realized that the Great Nothing was not a flaw in our vision, but a core component of the cosmic design. The legacy of that mission remains a cornerstone of modern cosmology. It taught us that the voids are not merely empty rooms in the house of the universe, but the very forces that shape the walls. The struggle to accept the Bootes void was the struggle to accept a universe that is far more complex and far more terrifying than we ever dared to believe. It was the moment we stopped looking for the dragons and started looking into the mouth of the abyss itself, finding that the most important part of the map might be the parts where nothing is written. To understand the existence of such a profound absence, one must first look to the skeleton of the cosmos itself. The universe is not a chaotic sprawl of matter, but a highly organized, interconnected network known as the cosmic web. This gargantuan structure is composed of vast, shimmering filaments of gas and dark matter that stretch across the light years like the silk of a celestial spider. These filaments act as the primary highways of the universe, funneled by gravity to channel matter toward massive junctions where hundreds of galaxies congregate in glittering clusters. This is the scaffolding of reality, a blueprint laid down in the first moments of time, and it dictates exactly where stars can ignite and where the darkness must prevail. The architecture of this web is best understood through the behavior of a simple soap bubble. When a multitude of bubbles are pressed together, they do not form solid spheres. Instead, they flatten against one another, creating a complex lattice of thin, translucent membranes that meet at sharp angles. The substance of the universe behaves in a strikingly similar fashion. Gravity, the tireless sculptor, acts upon the primordial gas of the early cosmos, pulling it away from regions of lower density and dragging it toward the stronger gravitational wells. Over billions of years, this process flattens the matter into thin sheets and long, rope-like filaments. These are the walls of the cosmic bubbles, the vibrant membranes where galaxies are born, collide, and thrive in a frantic display of light and heat. Inside these membranes, however, a different story unfolds. As gravity pulls the matter outward to build the walls and the filaments, it leaves behind hollow centers. These are the cosmic voids, the great interior chambers of the universe. Just as the air inside a soap bubble exerts an outward pressure that keeps the film from collapsing, the very expansion of space itself works to keep these voids hollow. In these regions, there is not enough matter to exert a meaningful gravitational pull. Without the weight of stars and gas to hold the fabric of space together, the expansion of the universe, driven by the mysterious influence of dark energy, takes hold with unrivaled ferocity. The voids do not merely sit empty, they actively swell, pushing against the surrounding walls of matter like an inflating lung. This creates a cosmic tug-of-war that has lasted for nearly 14 billion years. On one side is gravitational attraction, the force of gathering and compression, which seeks to pull all matter into dense singular points. On the other side is the expansion of space, the force of scattering and distance, which seeks to drive every particle away from its neighbour. In the dense filaments of the cosmic web, gravity is the undisputed victor, forging suns and black holes in a relentless pursuit of density. But in the vast reaches of the Bootes void, expansion has won the day. Here, the repulsive force of the vacuum has cleared the stage, driving the matter out toward the periphery until only the most tenuous whispers of hydrogen remain. The contrast between these two environments is the ultimate study in cosmic extremes. The walls of the web are sites of incredible violence and creation, where the density of matter is high enough to trigger the birth of billions of stars and the formation of complex planetary systems. These are the crowded cities of the cosmos, bustling with the energy of 1 trillion suns. In stark opposition, the interiors of the voids are the ultimate wilderness. They are realms of absolute stillness, where the temperature hovers just above absolute zero and the density of atoms is lower than the most perfect vacuum ever created in a human laboratory. These hollow interiors protect nothing but the purity of space itself, acting as the silent reservoirs of the universe's most basic ingredients. The Buddha's void is a titan among these bubbles, a supervoid that has transcended the typical scale of cosmic architecture. While most voids are relatively modest in size, the vacancy in Buddha's is so immense that it spans a distance that light would take over 300 million years to cross. It is as if several smaller bubbles have merged, their internal membranes dissolving to create a singular, colossal chamber of nothingness. This massive structure stands as a testament to the power of expansion. It is a place where the scaffolding of the universe has been stretched to its breaking point, leaving a hole in the web so large that it challenges our understanding of how the cosmic skeleton was built. In this grand design, the filaments and the voids are two sides of the same coin. The brilliance of the galaxies we see is only possible because the matter was drained from the spaces between them. The light of the Milky Way is, in a sense, a debt owed to the darkness of the voids. We live upon the thin, fragile membranes of a universe that is mostly hollow, clinging to the walls of a cosmic bubble that is drifting through an infinite sea of shadow. The Buddha's void is the most dramatic expression of this reality, a reminder that the architecture of existence is defined not just by the pillars of light, but by the magnificent, terrifying emptiness that holds them apart. The diameter of this chasm is 330 million light-years, a distance so vast that it exceeds the total span of over 3,000 Milky Way galaxies placed side by side. To move across this gap at the speed of light would require a journey lasting longer than the entire history of mammalian life on Earth. It is a monolithic absence, a region of space that has been so thoroughly emptied of matter that it challenges the very definition of a universe. If the average density of the cosmos is a crowded city, the boat's void is a single lonely house standing in the middle of a dark continent-sized wasteland. The dimensions of this place are not merely large, they are transformative, altering the way light, time and gravity interact within its borders. If our own home, the Milky Way, were positioned at the absolute centre of this great vacancy, the history of human thought would have been fundamentally different. For thousands of years, as our ancestors looked up at the night sky, they would have seen the familiar band of our own galaxy, the river of stars that we call home. They would have named the constellations and tracked the planets of our own solar system. But beyond the silver glow of our own galactic disk, there would be nothing. In our actual reality, the night sky is peppered with the faint fuzzy patches of neighbouring galaxies, like Andromeda or the Magellanic Clouds. In the centre of the Buddha's void, the sky beyond our stars would be an unyielding, absolute ink. There would be no distant lanterns to hint at a larger world, no cosmic neighbours to suggest that we were part of a greater collective. The astronomers of the early 20th century would have pointed their glass lenses at the sky and found a terrifying solitude. In the year 1920, when the great debate took place between Heber Curtis and Harlow Shapley over the scale of the universe, there would have been no evidence to support the existence of other island universes. In our timeline, Edwin Hubble used the massive telescope at Mount Wilson in the 1920s to identify Cepheid variable stars in the Andromeda Nebula, proving that it was a separate galaxy millions of light-years away. But for a civilization at the heart of the Buddha's void, Hubble would have looked through his eyepiece and seen only the void. He would have found no distant stars, no receding nebulae, and no evidence of an expanding cosmos. In this scenario, the human species would have remained convinced that the Milky Way was the entirety of existence. We would have believed that our galaxy was a solitary spark in an infinite, eternal darkness. This belief would have persisted not just for decades, but for centuries. It would not be until the middle of the 20th century, with the advent of incredibly sensitive radio telescopes and the most powerful orbital observatories, that the first hints of a world beyond the darkness would emerge. we would have spent the better part of our modern history in a state of profound cosmic isolation, unaware that the universe was filled with trillions of other galaxies, all hidden behind a wall of nothingness that light itself struggled to bridge. The psychological weight of this isolation would be staggering. In our current reality, we know we are part of the Virgo supercluster, a member of a cosmic community that is interconnected by the invisible threads of gravity. To be at the centre of the Boots void is to be a castaway on a planet that is not just a lonely world, but a lonely galaxy. The realization that we were not the only thing in existence would have arrived only after we had developed the technology to see across 300 million light-years of empty space. The shock of discovering the walls of the void, the dense, vibrant filaments of the cosmic web where the rest of the universe actually lives, would have been a scientific revolution of unparalleled proportions. It would be as if a person who had lived their entire life in a dark, sealed room suddenly opened a door to find a bustling, sunlit metropolis. This hypothetical scenario serves to emphasize the sheer, crushing scale of the Bhuta's void. It is a region of space that is capable of hiding the entire rest of the universe from view for almost the entire duration of a civilization's scientific development. The void does not just swallow matter, it swallows information. It acts as a barrier to understanding, a giant blind spot in the eye of the cosmos. The impossible dimensions of the abyss mean that light from the nearest external galaxy would have to travel for over 150 million years just to reach the centre. By the time that light arrived, the stars that sent it might have already burned out, leaving the observers in the void to study the ghosts of a universe they never knew existed. The Bhuta's void thus stands as the ultimate frontier of the imagination. It is a place where the scale of the universe becomes so large that it loses its meaning. We are used to thinking of the cosmos as a place of infinite variety and endless light, but the void reminds us that the vast majority of the universe is a silent, empty hall. It is a monument to the power of the vacuum, a 330 million light-year-wide testament to the fact that in the grand design of the great architect, the gaps are often more significant than the structures they separate. We are defined by our neighbours, but in the heart of the Bhuta's void there are no neighbours, only the long, slow passage of light through a desert that has no end. The mechanics of the great expansion are not uniform across the cosmic stage. While the entire universe has been growing since the first moment of the Big Bang nearly 14 billion years ago, the rate of this growth depends heavily on what occupies a given region of space. In the dense neighbourhoods of the cosmic web, the sheer mass of trillions of stars and the invisible weight of dark matter act as heavy anchors. These gravitational giants pull inward, resisting the outward surge of expansion and holding the fabric of space taut. But in the hollow heart of the Bhuta's void, there are no such weights. Here, the absence of matter has transformed the region into a gargantuan engine of expansion, a bubble of vacuum that is inflating with a ferocity unseen in the crowded corridors of the galaxies. The primary driver of this hollow growth is dark energy, a mysterious and pervasive force that appears to be a fundamental property of space itself. Dark energy does not clump together like matter. It is spread evenly across the entirety of existence, exerting a constant repulsive pressure that seeks to drive every point in space away from every other point. In the dense filaments where galaxies congregate, gravity is strong enough to overwhelm this repulsive force, keeping the stars locked in their orbits and the clusters bound to one another. However, as the density of matter drops, the influence of gravity fades. In the Bhuta's void, the density is so low, perhaps less than 1 atom for every cubic metre of space, that the gravitational brakes are entirely absent. Without the resistance of matter, the dark energy within the void is free to act upon the fabric of space with unbridled efficiency. The void functions as a gargantuan balloon inflating between the heavy anchors of the surrounding galaxy clusters. As the dark energy pushes outward, it causes the space within the void to stretch and swell. This is not a passive process. The void is an active participant in the shaping of the cosmos. As it inflates, it physically pushes the surrounding walls of galaxies further apart. The Great Nothing is not just a hole that exists because matter is missing. It is a swelling pressure that is actively clearing the stage, driving the matter toward the periphery and ensuring that the emptiness remains absolute. This creates a feedback loop that has dictated the evolution of the large-scale structure of the universe. As the void expands, the matter at its edges is swept up and pushed into the dense filaments of the cosmic web. This further reduces the density within the void, which in turn reduces the gravitational pull, allowing the dark energy to accelerate the expansion even more. Over billions of years, this process has turned the Buta's void into a titan. It has consumed the space around it, merging with smaller voids and pushing the boundaries of the known universe outward. The void is a realm where the expansion of space has achieved a sort of purity, unencumbered by the messy interference of stars, planets, or gas. The stretching of space within the void has profound consequences for the light that attempts to cross it. As the fabric of the vacuum expands, the very waves of light travelling through it are stretched as well. A photon of blue light, entering the void from a distant galaxy, finds the ground moving beneath its feet. By the time it has traversed the 330 million light-years of the abyss, its wavelength has been pulled and elongated by the relentless expansion of the space it occupied. It arrives on the other side, shifted toward the red, a weary messenger carrying the physical imprint of the void's growth. This redshift is the primary evidence of the void's active role in the Great Expansion, a measurable signal of the vacuum's power. In this sense, the Buta's void is the ultimate laboratory for the study of dark energy. It is a place where the most dominant force in the universe is allowed to operate in its most naked form. Everywhere else, the presence of matter obscures the true nature of the expansion, creating a complex interplay of attraction and repulsion. But in the void, the mask is stripped away. We see a region of space that is literally creating more of itself at an accelerating rate. A bubble of nothingness that is winning the war against the somethingness of the galaxies. The void is the vanguard of the future, a preview of a universe where the expansion of the vacuum has finally triumphed over the gathering power of gravity. The sheer scale of this inflation is difficult to reconcile with our terrestrial experience of space. We are used to thinking of space as a static background, a stage that remains fixed while the actors move across it. But the Buta's void reveals that the stage is alive. It is growing, stretching, and pushing. The impossible dimensions of the void are a direct result of this active participation. It is a 330 million light-year wide monument to the fact that in the grand cosmic tally, the energy of the vacuum is far more powerful than the mass of the stars. The void is not a failure of the universe to produce matter. It is the success of the universe in producing space. It is a kingdom of the expanding vacuum, where the great expansion is not just a theory, but a physical, overwhelming reality that defines the limits of the known. Yet even within this colossal theatre of the absent, the void is not an absolute zero. Scattered across the 330 million light-years of the abyss are a few rare, ghostly inhabitants that defy the surrounding nothingness. These are the void galaxies, ultra-faint and incredibly isolated stellar islands that lurk in the deepest shadows of the Butz region. They are the shyest objects in the known universe, so dim and distant that they remained invisible to human eyes until the most sensitive electronic detectors were trained upon the dark. These galaxies are the ultimate castaways, drifting through a lightless ocean with no shoreline in sight, and their existence provides a startling contrast to the frantic, crowded life found within the filaments of the cosmic web. In the standard regions of the universe, a galaxy is a product of perpetual violence and interaction. The Milky Way, for instance, is a cosmic cannibal, having spent billions of years devouring smaller satellite galaxies to fuel its own growth. In the dense clusters of the web, galaxies are constantly jostling for position, their spiral arms distorted by the tidal pulls of their neighbours, their gas clouds compressed into fiery nurseries where thousands of new stars are born in a single celestial instant. This is the chaos of the crowded places, a cycle of collision, merger, and rebirth that keeps the universe vibrant and changing. But inside the Buta's void, the rules of evolution are rewritten by the silence. A galaxy born in the heart of the void is a hermit, destined to spend its entire life in total, undisturbed solitude. Without the influence of nearby neighbours, there are no gravitational tugs to warp its shape or trigger the massive starbursts that characterize the galaxies of the web. These stellar islands grow in an eerie hermetic purity. They are time capsules of the early universe, preserving the primordial gas from which they were formed because they have never had it stripped away by a passing cluster or replenished by a merger. Their evolution is slow, rhythmic, and incredibly lonely. While a galaxy in a cluster might be compared to a bustling city, a void galaxy is a single, flickering candle in a darkened cathedral, burning its fuel with a measured, sombre patience. This isolation results in a strange skeletal appearance. Many of the few dozen galaxies discovered within the Bootes void exhibit unusual structures that are rarely seen in the busy parts of the cosmos. Some are shaped like long, spindly needles or thin, distended tadpoles, their forms never having been rounded out by the stabilizing influence of a larger group. They are often richer in gas than their urban cousins, yet they produce stars at a much slower rate. It is as if the very stillness of the void has lulled them into a state of cosmic stasis. They are the forgotten children of the Big Bang, ossified in a state of primordial simplicity that has remained unchanged for 10 billion years. The sheer rarity of these objects is perhaps the most haunting aspect of the Bootes void. In a volume of space this large, located anywhere else in the universe, an astronomer would expect to find at least 10,000 galaxies. In the Bootes void, researchers have been able to identify only about 60. This means that for every galaxy in the void, there are millions of cubic light-years of absolute unyielding vacancy. The distance between any two of these castaway galaxies is so immense that their inhabitants, should they exist, would have no way of knowing that another island of light exists anywhere in the cosmos. They would look out from their lonely stars and see a universe that is entirely perfectly black. This solitude preserves a unique kind of purity. Because these galaxies have never been disturbed, they offer a glimpse into what a galaxy looks like when it is allowed to age without the trauma of interaction. They are the control group in the great experiment of cosmic evolution. By studying the faint red light of their aging suns, astronomers can peer back into a version of history where gravity never quite managed to finish the job. They are the remnants of a failed architecture, the scraps of matter that were left behind when the rest of the universe was swept into the great filaments and clusters. The experience of these galaxies is one of profound, eternal silence. There is no cosmic background hum of 1,000 neighbouring suns, no radio interference from a nearby quasar, and no gravitational waves rippling through the local fabric of space. There is only the slow, cold rotation of a few billion stars around a quiet centre, surrounded on all sides by an impassable wall of shadow. They are the ultimate testament to the scale of the Bootes void, not because they fill it, but because they highlight just how empty the rest of it truly is. These 60 islands of light are the only witnesses to the 330 million light-year expanse, tiny flickers of defiance in a realm where the darkness has otherwise claimed a total and absolute victory. They are the ghosts of the abyss, haunting a space that was never meant for the living. The mathematical disparity at the heart of the Bootes void presents one of the most harrowing puzzles in modern astrophysics. When researchers calculate the sheer volume of this 330 million light-year wide chasm, the laws of probability dictate a certain density of matter. In any other corner of the observable universe, a space of this magnitude would be teeming with life and light, home to at least 10,000 galaxies, each containing hundreds of billions of suns. Yet, when the most powerful telescopes peer into this specific abyss, they count only 60. This is not a minor statistical deviation. It is a cosmic heist of unimaginable proportions. The question that haunts the scientific mind is not merely why the void is empty, but where the missing 10,000 galaxies have gone, and what force possessed the power to evict them. The answer lies in the invisible hand of dark matter, the unseen sculptor of the cosmic abyss. While the stars and gas clouds provide the light we see, they are merely the foam upon a much deeper and more mysterious ocean. Dark matter, which does not emit, absorb, or reflect light, constitutes the vast majority of the mass in the universe. It acts as the primary gravitational blueprint for all structure. In the early epochs of the cosmos, dark matter did not distribute itself evenly. tiny ripples in the density of the primordial soup meant that some regions had slightly more dark matter, while others had slightly less. These subtle differences were the seeds of the great filaments and the great voids. In the region that would become the Boots void, there was a slight deficit of dark matter at the beginning of time. This minor imbalance set a catastrophic process in motion. Gravity is a cumulative and relentless force. It rewards the heavy and punishes the light. As the surrounding regions of the cosmic web grew denser, their gravitational pull became stronger, acting like a series of massive siphons. The dark matter within the Botas region was slowly but surely dragged outward toward the growing walls and filaments. Because visible matter, the hydrogen gas and the dust that forms galaxies, is tethered to dark matter by gravity, it followed the invisible tide. The void was not born empty, it was systematically evacuated. This process transformed the Botas void into a gravitational highland, a peak in the landscape of space-time from which all matter seeks to flee. To understand the scale of this displacement, one must contrast it with the Great Attractor, a massive gravitational anomaly located hundreds of millions of light-years away in the opposite direction. The Great Attractor is the ultimate collector, a region of such immense mass that it pulls entire superclusters of galaxies toward its centre, like water spiralling down a drain. It represents the triumph of gathering. The Botas void is the antithesis of this phenomenon. It is the great repeller, a place where the lack of mass creates a repulsive effect. It does not push matter away with a physical force, but rather, the surrounding universe pulls so much harder that the void is left behind, hemorrhaging its contents into the hungry maw of the cosmic web. The missing 10,000 galaxies are not truly gone. They are the refugees of the abyss, now huddled together in the dense, vibrant walls that border the void. They have been integrated into the massive filaments of the Hercules and Corona Borealis superclusters, their identities lost in the crowded glare of the celestial cities. The 60 galaxies that remain within the void are those rare few that were caught in the exact centre of the clearing, too far from any wall to be effectively pulled away, or perhaps possessing just enough local dark matter to resist the outward tide. They are the leftovers of a cosmic purging, the evidence of a struggle for dominance between the places that have everything and the places that have nothing. This struggle defines the very soul of the universe. The existence of the Botas void suggests that the large-scale structure of reality is dictated more by what is missing than by what is present. The dark matter sculptor does not just build galaxies, it carves out the spaces between them. The void is a masterpiece of negative space, a 330 million light-year wide testament to the power of the invisible. It challenges the human tendency to focus on the light, forcing a realization that the vacuum is an active, shaping influence. The mathematical absence of those 10,000 galaxies is the most profound signal we have of how the universe truly works, not as a collection of objects, but as a dynamic, shifting balance of density and vacancy. In this cosmic tug-of-war, the voids are currently winning. As the universe continues to expand, the gravitational siphons of the filaments are becoming less effective over vast distances, while the repulsive pressure of the empty spaces driven by dark energy grows stronger. The Botas void is a preview of the ultimate fate of the cosmos, a realm where the evacuation is nearly complete. It stands as a silent witness to the fact that matter is a fleeting passenger in a universe that is increasingly defined by its holes. The mystery of the missing matter is the story of the universe's own growth, a narrative where the shadows eventually grow long enough to swallow the suns, leaving behind only the cold, perfect logic of the abyss. To find the true genesis of this 330 million light-year wide silence, the gaze must shift back across the eons, past the birth of the first stars and the formation of the earliest galaxies, to the very first second of existence. The Botas void was not an accidental byproduct of a maturing universe. It was a destiny written into the primordial soup during the era of cosmic inflation. In those first fleeting fractions of a moment following the Big Bang, the universe was a roiling, microscopic cauldron of energy. Within this subatomic chaos, the laws of quantum mechanics dictated that space could never be perfectly smooth. Tiny, flickering jitters known as quantum fluctuations pulsed through the infant cosmos, creating regions of space that were ever so slightly denser than their surroundings, and others that were ever so slightly more vacant, as the universe underwent a period of exponential expansion. These microscopic ripples were caught in the surge and stretched to gargantuan proportions. What was once a subatomic jitter became a cosmic blueprint. The regions of slightly higher density would eventually collapse under their own weight to form the great filaments of the cosmic web. Conversely, the regions that began with a fractionally lower density became the seeds of the great voids. The Buddha's void began its life as one of these subtle underdensities, a shallow depression in the landscape of the early universe. It was a place where the energy of creation was spread just a little thinner, a whisper of absence in a scream of light. Evidence of this ancient origin is etched into the very oldest light in the universe, the cosmic microwave background radiation. This is the afterglow of the Big Bang, a fossilized snapshot of the cosmos taken just 380,000 years after the beginning of time. At that moment, the universe had cooled enough for atoms to form, allowing the trapped photons to finally break free and stream across the darkness. Today, this light reaches our telescopes as a uniform hum of microwave energy, but it is not perfectly smooth. When mapped with extreme precision, the cosmic microwave background reveals minute variations in temperature, faint splotches of orange and blue that represent the hot and cold spots of the infant sky. The Buddha's void leaves its fingerprint upon this map as a distinct cold spot. Because the region that would become the void contained less matter, the ancient light passing through it was affected by the unique gravitational landscape. As photons climbed out of the shallow gravitational well of the underdense region, they lost a tiny fraction of their energy, shifting toward a cooler temperature. This ancient radiation acts as a prehistoric map, a glowing testament to the fact that the Great Nothing has been a feature of our reality since the light first found its way through the dark. The cold spot in the background radiation is the ghost of the void's infancy, a signal that has travelled for over 13 billion years to tell the story of how a tiny quantum fluctuation grew into a monster of the abyss. Over the subsequent billions of years, the relentless logic of gravity amplified these initial deviations. The surrounding regions, enriched by their slightly higher concentrations of dark matter and gas, began to pull harder on the contents of the proto-void. It was a process of slow, inevitable siphoning. Every atom that drifted toward the edge of the underdensity was captured by the growing gravitational influence of the neighbouring filaments and never returned. The void did not just sit still, it deepened and widened, its internal pressure dropping as its substance was stolen by the surrounding walls. The tiny seed planted in the first second of time blossomed into a cavernous hole, a 330 million light-year-wide testament to the power of initial conditions. This connection between the subatomic and the supergalactic is one of the most profound realizations of modern science. It suggests that the largest structures in existence, the great voids that swallow the imagination, are simply the magnified reflections of the smallest events possible. The Buddha's void is a quantum scar on the face of the cosmos, a reminder that the macrocosm is forever bound to the microcosm. The ancient radiation of the cosmic microwave background serves as the bridge between these two worlds, allowing us to see the exact moment when the nothingness began to take shape. It reveals a universe that is a single, continuous narrative, where the silence of the Buddha's region is the long-delayed echo of a microscopic tremor that occurred when the universe was less than a billionth of a second old. In this light, the void is not a lack of history, but a preservation of it. While the galaxies have been churned and recycled by billions of years of stellar evolution and galactic mergers, the void remains a relatively pure expression of the early universe's geometry. It is a place where the original architecture of the Big Bang has been allowed to stand, undisturbed by the clutter of matter. To study the Buddha's void is to read the opening chapter of the Book of Time, a chapter written in the language of density and vacancy, recorded in the cooling embers of the first light, and expanded into the terrifyingly vast reality we observe today. The abyss is the memory of the beginning, a silent monument to the first second of forever. The current architecture of the Buddha's void is the product of a slow and relentless process of cosmic cannibalism. It did not spring into existence as a singular 330 million light-year wide chasm. Rather, It is a conglomerate of smaller absences that have merged over the course of billions of years. In the younger universe, this region of space was likely a dense honeycomb of smaller voids, each perhaps only tens of millions of light-years across. These pockets of nothingness were separated by thin, fragile membranes of matter, tenuous bridges of galaxies and gas that struggled to maintain their integrity against the growing pressure of the vacuum. The process of void merging is a slow-motion catastrophe that plays out over eons. As the expansion of space within these smaller pockets continues, driven by the unwavering push of dark energy, the walls between them are stretched to their breaking point. Gravity, meanwhile, continues to siphon matter away from these thin bridges, pulling the remaining gas and stars toward the larger, denser intersections of the cosmic web. Eventually, a bridge becomes too depleted to hold itself together. The gravitational tether snaps and the wall dissolves. In that moment, two smaller voids become one. The shadows of one region bleed into the shadows of the other, creating a larger, more formidable absence. This is the predatory nature of the vacuum. A larger void possesses a distinct advantage over its smaller neighbours. Because it contains less matter, the repulsive force of dark energy is even less opposed by the inward pull of gravity. This allows the larger void to expand at a slightly more aggressive rate, exerting a literal pressure on the surrounding filaments. It pushes against the walls that define its boundaries, thinning them from the inside out. Over hundreds of millions of years, the Bhuta's void has acted as a cosmic predator, consuming the smaller pockets of nothingness that once surrounded it, absorbing their volume and erasing the structures that once separated them. The Great Nothing is, therefore, a graveyard of lost filaments. Within its current boundaries there were once countless bridges of light, thousands of galaxies that were once part of a more intricate, smaller-scale web. As the voids merged, these galaxies were either pushed out into the massive walls of the current supervoid, or were left as the lonely, isolated castaways we observe today. The 60 galaxies that remain are the stubborn remnants of these dissolved bridges, the last pieces of a puzzle that has been largely erased by the merging of the shadows. They are the survivors of a process that has turned a complex network of small rooms into a single echoing hall. This process of consolidation is far from over. The Bhuta's void continues to grow, its boundaries creeping outward as it prepares to consume the next layer of the cosmic web. It is a slow-motion wave of absence, moving through the universe and dismantling the scaffolding of matter. To the north and south of the void, there are smaller underdensities that are already beginning to feel the influence of the Great Nothing. The walls between them are thinning, the galaxies within them are being pulled away, and eventually they too will be absorbed. The abyss is an active, hungry entity, a 330 million light-year wide bubble that is still inflating, still merging, and still refining its perfect emptiness. This theory of merging explains why the Bhuta's void is so much larger than the average void found elsewhere in the sky. It is a supervoid, a champion of the vacuum that has won more battles than its peers. It represents a state of advanced cosmic evolution, a glimpse into a future where the merging of voids is the primary mode of structural change in the universe. In the grand timeline of the cosmos, the era of galaxy formation and stellar birth is merely the first act. The second act belongs to the voids. As the stars burn out and the galaxies drift further apart, the voids will continue to merge and grow, consuming the remnants of the cosmic web until the boundaries between them disappear entirely. The Bhuta's void is the vanguard of this dark future. It is a realm where the walls have already fallen, where the bridges have already snapped, and where the nothingness has achieved a scale that dwarfs the structures of light. Its existence proves that the universe is not just expanding, it is hollowing itself out from the inside. The cannibalism of the voids is the mechanism by which the universe transitions from a state of complexity to a state of absolute, unyielding simplicity. Every time two voids merge, a piece of the cosmic web is lost forever, and the Great Nothing grows one step closer to its final, all-encompassing form. The abyss does not just exist, it conquers. The conquest of the abyss is not merely a matter of volume, but of energy and temperature, a truth revealed through the thermal signature of the early universe. The cosmic microwave background, that ancient afterglow of the first moments of creation, serves as a fossilized thermometer of the infant cosmos. To the untrained eye, this radiation appears uniform, a steady hum of microwave energy that permeates every corner of the sky at a temperature of approximately 2.7 degrees above absolute zero. However, when the most sophisticated orbital observatories map this radiation with a precision that accounts for variations of a few millionths of a degree, a chilling anomaly emerges. In the direction of the constellation Boötes, there is a distinct and inexplicable drop in temperature. This is the cold spot, a thermal fingerprint that marks the location where the great nothing has drained the very warmth from the light of the beginning. To confirm the existence of this invisible giant, cosmic surveyors have turned to the most distant and powerful beacons in the known universe, the quasars. These are the frantic, brilliant hearts of infant galaxies, powered by supermassive black holes that consume entire solar systems to produce a radiance hundreds of times brighter than the entire Milky Way. Located billions of light-years away, these quasars act as celestial lighthouses situated on the far side of the abyss. Their light must traverse the entire 330 million light-year span of the Boötes void before it can reach the lenses of human telescopes. As this light pierces the darkness, it becomes a tool for mapping the invisible, carrying with it a record of every gravitational hurdle and every pocket of expanding space it encountered on its journey. The technical genius required to interpret this light relies on a phenomenon where the expansion of the void physically robs the passing photons of their energy. As a photon from a distant quasar enters the Boötes void, it rolls down a gravitational hill into the shallow depression of the underdense region. In a static universe, the photon would gain energy as it fell in and lose an equal amount as it climbed out the other side, resulting in no net change. But the Boötes void is not static. It is a swelling bubble of dark energy. While the photon is in the process of crossing the chasm, the void expands. The gravitational hill it must climb to exit is flatter and longer than the one it descended. Consequently, the photon emerges on the other side with less energy than it had when it entered. This loss of energy manifests as a shift toward the red end of the spectrum and a corresponding drop in temperature. By meticulously measuring this subtle loss of energy in the light of thousands of ancient quasars, astronomers have been able to trace the invisible boundaries of the abyss. They have mapped the void not by looking at what is there, but by calculating the specific ways in which the nothingness has tired the light. This process reveals the void as a massive three-dimensional lens that distorts the backdrop of the universe. The cold spot in the cosmic microwave background is the ultimate evidence of this effect, a region where the photons have been so thoroughly exhausted by their journey through the expanding vacuum that they arrive at our detectors significantly cooler than the surrounding radiation. It is a chilling realization. The Boötes void is so vast and is expanding so rapidly that it leaves a measurable scar on the oldest light in existence. This mapping of the invisible has forced a reconsideration of the void's role in the cosmic hierarchy. It is no longer seen as a passive absence, but as a thermal and gravitational sink that actively shapes the energy distribution of the universe. The surveyors have shown that the boundaries of the abyss are not sharp walls, but gradual transitions where the density of matter slowly fades into the absolute vacuum of the interior. Using the light of the quasars, they have identified the precise points where the gravitational influence of the cosmic web fails, and the repulsive pressure of the void takes command. These boundaries represent the front lines of a battle between matter and the vacuum, a struggle that is written in the shifting wavelengths of light and the cooling temperatures of the sky. The ability to see the invisible through the behavior of a light is the crowning achievement of modern cosmic cartography. It allows us to look into the Boötes void and see it not as a black hole in our data, but as a physical entity with a measurable temperature and a clear structural form. The cold spot is a monument to the scale of the abyss, a 330 million light-year wide testament to the fact that the vacuum is a thief of energy. In the silence of the Boötes region, the light itself grows cold, a weary traveller that has been stretched and drained by a realm that thirsts for the very substance of reality. The maps produced by these surveyors are the most profound records we possess of the Great Nothing, revealing a universe where the shadows are cold, the light is tired, and the vacuum is the ultimate master of the landscape. As the clock of eternity ticks forward, the Boötes void ceases to be a cosmic anomaly and instead becomes a prophecy of the universal endgame, The accelerating expansion of space, fueled by the inexorable and mysterious pressure of dark energy, is a process that cannot be halted or reversed. In the current era, the cosmic web still holds, its filaments of dark matter and gas acting as the connective tissue of reality. But the balance of power is shifting. With every passing billion years, the repulsive force of the vacuum grows stronger, while the gravitational grip of the galaxies grows weaker as they are driven further apart. The future is a slow-motion unravelling of the tapestry of light, a time when the great voids will finally rise to claim their total inheritance. The first stage of this dissolution is the thinning of the cosmic threads. The long shimmering filaments that currently link superclusters of galaxies will be stretched until they are nothing more than tenuous whispers of hydrogen. The bridges of light that have spanned the darkness for billions of years will eventually snap, severed by the relentless growth of the space between them. One by one, the neighbouring clusters of galaxies will be pushed beyond the cosmic horizon, a boundary across which light can no longer travel. The sky, once a crowded map of distant lanterns, will begin to dim. The galaxies of the Hercules and Corona Borealis superclusters, which today define the borders of the Bhuta's void, will vanish from view, their light stretched into infinity by the expansion of the abyss. Eventually, the universe will transform into a collection of isolated islands, each marooned in its own private Bhutas-like void. Our own local neighbourhood, the remnants of the Milky Way and Andromeda, merged into a single stellar graveyard, will become a solitary spark in an endless sea of shadow. To any observer remaining on a planet around a dying star in that far future era, the universe will appear to have returned to a state of primordial darkness. They will look out into the night and see no other galaxies, no distant nebulae, and no evidence that anything else exists beyond their own gravitational reach. The isolation that would have been a hypothetical scenario for a civilization at the centre of the Bhuta's void today will become the absolute reality for every corner of the cosmos. The voids, having won the battle for dominance, will continue to merge and expand until the concept of a void loses its meaning, for there will be nothing left to define its boundaries. The universe will have hollowed itself out so completely that the distance between any two particles of matter will exceed the diameter of the observable universe today. The energetic drama of the stars, the mergers, the supernovae, and the birth of planetary systems will be a forgotten chapter of an ancient history. In its place will be a singular, perfect vacuum, a realm where the temperature has dropped to the very edge of absolute zero, and where the passage of time is marked only by the slow, cooling embers of the last black holes. This is the victory of the nothingness. The cosmic web, the grand architecture that once governed the distribution of all matter and energy, will have been dismantled by the very expansion that gave it life. The threads will have snapped, the walls will have fallen, and the great bubbles of the voids will have burst into a single, infinite ocean of dark. The Bhuta's void is merely the first of these bubbles to achieve such terrifying proportions, a vanguard of the coming shadow. It provides a glimpse into a state of existence where the light is not just rare, but impossible, a future where the vacuum is the only thing that remains. In this far future cosmos, the entropy of the void becomes the ultimate graveyard of information. Every signal, every memory of the vibrant universe of the past will be stretched into a wavelength so long that it can never be detected. The universe will have transitioned from a state of light and heat to a state of absolute, unyielding cold. The silence that currently haunts the Bhuta's region will become the universal standard, an eternal and unchanging quiet that marks the end of the cosmic story. The light will have been the exception, a brief and frantic flicker in the long dark history of the vacuum. The voids do not just win the battle, they inherit the universe, turning the grand architecture of the stars into a memory of a shadow, lost in a desert that has no end and no beginning. The void is the ultimate destination of all entropy, the final resting place for the heat of the Big Bang and the light of every sun that has ever burned. In these 330 million light-years of silence, the information of the universe, the complex arrangements of atoms that form planets and people, is dissolved into a state of maximum disorder. It is a graveyard where the energy of the cosmos is spread so thin that it can no longer perform work, a realm where the vibrant history of the stars is stretched into a flat, featureless horizon. But to see the void only as a tomb is to miss the fundamental paradox of our existence. This graveyard was also a womb. The terrifying scale of the Bhuta's void is not a mistake of nature, but the very reason the stars were able to ignite in the first place. In the early epochs of the cosmos, the universe was a uniform fog of hydrogen and helium. If that fog had remained perfectly distributed, the gravitational pull would have been equal in every direction, and the matter would have stayed suspended in a lukewarm, eternal haze. The stars would never have kindled, and the galaxies would never have formed. It required the presence of the voids to break the symmetry. As these pockets of nothingness began to swell, they acted as the invisible hands of a cosmic sculptor. By exerting an outward pressure, the voids pushed the primordial gas away from their centres and into the narrow, crowded channels of the cosmic web. The great nothing was the engine of density, the force that squeezed the formless clouds until they grew hot and heavy enough to collapse under their own weight. We are the children of the crowded places, the residents of the bright walls, but we are forged by the emptiness that surrounds us. Every atom in the human body, every carbon bond in our DNA, and every iron crystal in our blood was produced in the hearts of stars that were forced into existence by the pressure of the voids. Without the Bhuta's void and its kin to clear the stage, the dust would never have gathered into the hearts of men. The abyss is the architect of the light. It is the silence that allows the song of the stars to be heard, the shadow that gives the flame its form. We exist in the narrow margins of the cosmic web only because the voids have claimed the rest of the territory for themselves. This realization transforms the fear of the abyss into a profound sense of gratitude. The scale of the Bhuta's void, which once seemed to mock our insignificance, now serves as a measure of the incredible effort required to create a single star. It took the evacuation of 330 million light-years of space to provide the material for the galaxies that border it. The emptiness is the price of the light. In the grand economy of the cosmos, the voids are the necessary sacrifice, the vast reservoirs of nothingness that allow the rare and precious somethingness of life to flourish. We are the heirs to a universe that is mostly hollow, clinging to the vibrant membranes of a reality that has been meticulously hollowed out to make room for us. The greatest miracle, however, is not that the universe is so large and empty, but that it has produced a way to be seen. In the midst of this colossal theatre of the absent, a collection of atoms on a small blue world has developed the capacity to look back. We are the universe observing itself, the consciousness that has emerged from the dust to contemplate the vacuum. When we point our telescopes at the Bhuta's void, we are the light of the cosmos staring into its own shadow. This act of witnessing is what prevents the void from being truly empty. By naming it, by measuring it, and by understanding its history, we fill the abyss with meaning. We provide a coordinate in the dark, a point of reference that turns a meaningless vacancy into a landmark of human achievement. Even in the far future, when the expansion of space has driven every other galaxy beyond our horizon, and the voids have finally won their battle for the universe, the legacy of the witness will remain. The fact that there was once a moment in time when a species looked into the great nothing and understood its purpose ensures that the darkness can never be absolute. We are the meaning makers in a machine of entropy, the flickering candles that define the dimensions of the cathedral. The Bhuta's void is not just a hole in the sky. It is a reminder that even in a universe of near infinite nothingness, the fact that we are here to witness it is the ultimate defiance. We are the light that looks back into the dark, and in the quiet, steady gaze of our understanding, we ensure that the void is never truly alone. The silence of the abyss is not a lack of sound, but a space waiting for our voice to fill it.